There are three types of symmetric figure to consider in polar graphs. One is the x-axis, which we call the polar axis, this line right here, and y-axis, which we call theta equals to pi over 2, and the origin, which is the pole. So first, you have to understand, just like in the regular function graph, even and odd, when you plug in negative x to f of x, and if it becomes positive f of x, it's even. So if you want to see if it's symmetrical on the x-axis, when you plug it in r theta, it should equal to this point because it reflects on the x-axis. So what is this point in terms of r? Same radius, but let's say this is 30 degrees, then that's negative 30. If you look at the negative r from here, this is 30. So this is then 150, which is 180 minus 30, which is 180 minus theta, which is pi minus theta. So for the x-axis symmetry, when you plug in these two instead of r and theta, and if it becomes exact same equation, then it's symmetrical on the x-axis. For y-axis, from here to here, this is same thing as what? This theta right here, if this is theta, same reference angle, so it's pi minus theta, right? This is pi minus theta, so when you plug it in r, comma pi minus theta, and negative r will be negative theta, and if it becomes exact same equation, then it's symmetrical on the y-axis. What about across the pole? If you have r comma theta, and then if you go to the other side, it's negative r comma theta. And here you have r comma pi over theta. Okay? So to summarize this, if it is symmetrical across the x-axis, you replace r theta by r comma negative theta and negative r comma pi minus theta. Or it doesn't have to be both, one or the other. Then it's symmetrical on the x-axis. Here's the y-axis, and this is for the origin. And here's some identities that you have to review. Sine of negative theta is odd function, so it becomes negative sine of theta. Cosine is even, right? Cosine is even. So negative theta becomes cosine theta. Co-function identity, sine pi over 2 minus theta is cosine theta. Cosine of pi over 2 minus theta is sine of theta. And here's the sum and difference identities. This formula will be given to you. Sine alpha plus theta will be sine cosine plus is still plus cosine alpha sine theta. So when we check the x-axis symmetry, we plug it in r comma negative theta. Let's do that first. So instead of r, you put r, which is r. So now it's 2 sine of 2 theta. You plug it in r and negative theta. R is just r. Now theta is negative, so you put negative 2 theta. Okay? So r equals 2. 2 times sine of negative theta becomes what? Negative 2 sine of 2 theta. Is there anything else we can do? No. So are these two identical? No. So the first one did not work. But that doesn't mean it is not symmetric across the x-axis. You have to try the second one. It has to work for either one. Doesn't have to work for both. It can be one or the other. So the second one is now negative r comma pi minus theta. So again, instead of r, now I plug it in negative r equals to 2 sine of 2 theta now, which is pi minus theta. And you have to simplify it. Huh? Negative r. Negative r. So now negative r equals to 2 sine of, so here's double parentheses, right? What's 2 times pi? 2 pi. What's 2 times theta? Minus 2 theta. So this becomes what? The difference of sine. So what was the difference of sine? It is sine, cosine, cosine, and sine. And if it's minus, you still have what? Minus. So negative r equals to 2 times sine 2 pi cosine 2 theta minus sine 2 theta cosine 2 pi. So negative r equals to 2 times what sine of 2 pi? In the unit circle, it is 0. So 0 times anything becomes 0 minus, what is cosine of 2 pi? 1. 1 times sine of 2 theta. So I get negative r equals to 2 times 0 minus sine square 2 theta is negative sine 2 theta. So I get negative r equals to 2 times negative is negative 2 sine of 2 theta. So what can I do if both sides are negative? You can divide by negative 1. So I get r equals to 2 sine of 2 theta, which is exact same as the equation given, isn't it? So you put a big check. So yes, this one is symmetric about the x-axis, or what's x-axis? It is polar axis. Symmetric on the y-axis. So y-axis, you have to try these two, negative r and negative theta. So now it's negative r equals to 2 times sine of negative 2 theta, right? Because theta now becomes negative. So sine is an odd function, so it becomes negative r becomes negative, goes outside. Negative 2 sine of 2 theta. When you divide by negative 1 from both sides, r becomes 2 sine of 2 theta, which is our original equation. So yes, this one is symmetry across the y-axis, which is the theta equals to pi over 2. Okay? So for now, 2 sine of 2 theta, you should already know how it looks like. It's sine rows with length of 2 for the paddles, and 2 is even, so it's 2 times n number of paddle, which is 4. So it will be even, so it will look something like this, right? And this length is 2. So yes, this was symmetrical on the x-axis, y-axis, and probably on the pole too. But here we're going to solve it algebraically, or prove it algebraically. Negative r comma theta, let's try this one first. So negative r equals to 2 sine of 2 theta. Obviously, they're not the same. So now you try the next one. R comma pi plus theta. So it is r equals to 2 sine of 2 pi plus theta. Double parentheses. So r equals to 2 sine of 2 pi plus, when you distribute 2 theta. So this is the sum of the sine. So it's r equals to 2 times sine of 2 pi cosine of 2 theta plus sine of 2 theta cosine of 2 pi. So r equals to 2 times sine of 2 pi on the unit circle is 0. So this becomes 0 plus this becomes cosine of 2 pi is 1. So it becomes sine of 2 theta, which is exact same equation as given. So yes, it is symmetric about the origin. So this one, as we expected, it's across the x-axis, y-axis, and pole, symmetrical.